Right, so welcome to the talk. So this is about remembering things and about the importance of time and a story of time travel, right? So what if your database never forgot, right? So let's go into that. But before that, I wanna so I wanna emphasize on certain phrase first, never forget. A lot of us have seen this in a lot of different contexts, good, bad. That depends again, like what the context was. But here, let's try to do it in a way that we never forget where we came from, never forget what made us, right? And and to quote a really famous German band, hast du etwas Zeit für mich, dann singe ich ein Lied für dich, which translates to, do you have some time for me? Then let me sing a song for you, right? So here the keyword being time or Zeit in German. And in the song 99 Love Balloons, this is pretty much the entrance for it. And if you all have some time for me, I'll sing a song for you all as well. Okay? So for that, I'll introduce myself a bit. So I'm Rahul there. I go by Lispy Clouds. I'm currently wearing a red Thoughtworks t-shirt. And I'm coming to you from the sunny Berlin, the rarely sunny Berlin, let's say. Yeah. And we are blessed with good weather here. And short hair, but shorter than I would like to, given the corona pandemic. So that's that. I do a lot of function programming, Clojure especially, infrastructure, teaching a lot here and there. And if any of the things that interests you on the slides, I'm quite ready to have a very emotional discussion on any of these things, right? So you can hit me up as Lispy Clouds on the internet. I'm happy to continue the discussion there as well. So before going in, some content warning, because we talk a lot about history. There are depictions of extremist right-wing imagery here, especially in the historical context, and which I think is important for us to remember where we come from, and also sets a good stage for the thing that I want to talk about. So Berlin, let me begin there. So it's a place that I currently live, know and love. It's a place with a varied, colorful history. I'd seen a lot of stuff, especially in its history, given the kind of history it has. And looks like it's quite empty right now. Probably the pandemic's going on. Right? But if you look at history, Berlin has seen some things. Berlin has been flattened literally in the World War, in a lot of skirmishes, fights, things like this. And that is still there in our minds. So Berlin has gone through a lot of not just physical changes, but mental perspective changes as well. A lot of people saying how to think, what to think, and things like this. So that's, I think, what shapes Berlin to the current thing, what it is. And apart from all of that trauma, Berlin had a wall. After the war around 60s, again, a lot of factors culminated into Berlin having a wall, being divided into East and West Berlin, and not just Berlin, but the whole German country. So that brought in its own set of problems again. So divided thinking, people thinking certain things on this side of the wall, that side of the wall, families being decided, pretty much separated on various lines. But common sense prevailed, and we finally got the wall down in the 90s. And there you have Nina there with her 99 air balloons here, right? So that's the current Berlin that we know and love. And I believe that that's what makes Berlin what it is. The fact that it had such a, what do you say, diverse history, and I wouldn't say diverse in all aspects, right? So let's look at this word fact. Right? So facts are something that's there, that's true, and you don't forget about things, right? So facts are something that has happened and you can't really deny it. Right? But some of us do tend to forget. And especially given the kind of history Berlin has, or Germany has, or even the world has, we do forget the fact that why we had those wars, why we had these things, and why we had this difference of ideas, right? We are seeing a resurgence in neo-Nazism, in again, racial-based hate and things like this. And we are again forgetting the fact that we had a lot of turbulence because of these things, right? So just to put it all together, facts, data, information, these are immutable, right? So they don't change. So they accrete over time. By accrete, what I mean is we accumulate things like a layer, like an onion, and we keep on remembering things, right? So we have seen ledgers or bookkeeping things. So we don't really change page erasers. We just accrete more and more things. Right? And in most places, I want to say history is immutable because we want to know what and where we came from, right? So I want to ask this question: that are our computers like that? So do we as programmers think in the same way while we are writing code, right? So let's take this Pythonic language. I want to say Pythonic because some places it might not be Pythonic, but algorithmic language. So we have a list of numbers and an empty doubles list. And for each of these numbers, we append the double of each number to that list, right? And then we forgot the fact that the double list was empty. Right? So again, we forget things, right? But there are a recent set of or I wouldn't say recent, but like set of languages that has been there with us, but there is a recent resurgence of these languages. So functional languages, Clojure, Haskell, Scala, good parts, or F#. So these things emphasize us not to forget things, right? Constant variables, immutable things, immutable data structures as well, right? So if we can rethink our algorithm in a different way of finding doubles, we could say we have a number list, and then we add, we just map over the list with a lambda being an anonymous function. So given a number, we'll return the double of it, and then we'll accumulate that into doubles, right? So nothing changed here. So we are still immutable, right? So we just mapped over things and then we did it. Right? But are our disks like that? Are our databases like that? So yes, we have a way to not change things while we are writing code, but can we say the same when we are interacting with a disk or a DB, right? So I would say a lot of us are very familiar with the CRUD mindset: create, read, update, delete. So here's a sample pseudocode which says that we can add city, get city, update city, and delete the city, right? So if you see, the two things that are important here is update and delete. So these two things are again making the DB or the disk forget things, right? Forget what it was. Okay? And this is where I would want to welcome you all to think in a different way, right? So we have made significant effort in our programming languages, but something happens in the disk, right? So can we do that there as well? Right? So what are these mainstream databases? So these generally are in this updating, changing mechanism. So we update things, we change things, we move things around. We need quite elaborate locking things going on. And in order to just model that mutable substrate, that thinking has crept into the language as well. That's my belief, that because our databases are like this, we start thinking like that in our languages as well. And that brings us a whole sort of problems as well, right? So again, did we forget something? So let's always keep this in mind, not to forget things, right? So to quote Nena again, hast du etwas Zeit für mich? So do you have some time for me? So time again is the time, and again I'm saying time is the thing. So let's focus on this word time, Zeit here in German. So I would want to say most, if not all, of the mainstream databases that we're used to for a while, they don't account for time or accretion or value of flow of facts, right? So because of the things that I mentioned before here, so we change data, we change structure, we have to have things like separate databases for analytical operational purposes, because we are not remembering what these things are, right? So, and then we have to have append-only strategies, and then maybe how many of us have a field called created at, updated at, deleted at, and how many of us have actually deleted something from the database, right? So we don't delete anything anymore. We just mark them deleted, right? So these are things that are there because we don't give time the importance that it needs. And I want to also challenge you to the fact that there is no business use case that time is not important. We need the flow of time for everything, pretty much. So here's a table which has city names, populations, and the country that it belongs to: Berlin, Barcelona, London. We have the population there, and then in traditional sense, we go and update the population, right? So it was less and now it changes, right? So, but then we forgot the fact that it was something else again, where we came from, right? So that's our traditional view of things, right? So why are we here? Why do we think like this? That's probably the crux of the matter here, I guess. So I want to hypothesize that that's something that's a relic of the past, because we had pretty less disk, pretty less RAM as well. So we had to reuse whatever we could. So if you think about it, immutability function programming, these are way older than languages like Fortran, C, and C++. So we took a while to catch up with the functional languages. And let's try to do that with the DB as well. Right? So again, so if you think about it, because of those reasons, we were imperative. Because of those reasons, we still have this CRUD mindset. We want to update things. We want to conserve memory, right? And functional programming is solving that in a lot of languages now. But still, like the core of it is still there, right? And if you think of it, that a lot of us have agreed that global variables are bad, right? We don't want to have too many global things lying around. But what about the DB? How many of us think that this DB itself is a mutable global variable here? And we just leave a lot of it to the DB that, okay, the DB will figure it out. I'm just going to hammer it whenever I can. So let's not do that. Right? So this, for me, is the impedance to scale. We do not have a way to move forward because we have the shared state, and then we can't scale because we have more and more cores. So can programming be liberated from the von Neumann style? So John Backus, some of you may know, is the person who came up with the Backus-Nord form, the way we write grammars for compilers. So in his ACM proceeding, he said, can be liberated from the von Neumann architecture, which defines the way all our CPUs are right now. We have rewritable, mutable substrate there, right? Each registers can be changed, right? So because of that, languages like C, Fortran, Algol, these came up. They directly model the substrate. But now we as programmers have become machines as well while we are writing code. We can't think in terms of abstract declarative sense that much, right? So can it be liberated? So it's again a paper that I would encourage you to go through. So Rich Hickey, the creator of the Clojure language, in his talk, Are We There Yet? A highly recommended talk. He talks about the epochal time model where we see state as a series of flowing values. And state is defined as when, at what point of time we observe it. We all started as kids. None of our parents see us as grown adults, I guess. We still are the kids to them. But they all refer to you as at the time of progression. Right? So each value is progressed upon by time and it's changed by a pure function. So let's try to see things in these ways instead of saying age plus plus or fuel minus minus. Right? Let's not change things in place. So again, have a look at it. Are we there yet? It's a critical view of time in object-oriented languages. So can we do that here? So can we start doing this with the database itself? Right? So here I want to talk about temporal databases, a bit different from time series database, I would say. So why I'm saying they're a bit different, because these databases truly embed the feel of what it means to be immutable. So we don't simply accrete things. We just accrete the differences, why we change things. Do we really need to change these kind of things, right? So these databases, especially CRUD, something that I'm going to mention especially here, they said that wir haben viele Zeit for this, so we have a lot of time for it. So yes, time is back again. And all of these databases, they have a lot of time in them. Right? Before going there, let's look at something that's quite familiar to most of us, if not all of us, version control systems, or Git in specific. So I think everyone who has used Git would say that I don't want to do software development in any other way now, right? So Git offers us a way to have history, have changes, have values. So each commit that you make is a point in time fact of what happened, right? And you go in and collaborate with people, you know why these things happen. A lot of us come back and read messages the next time, right? And not only that, we also can maintain parallel histories via branches, and then we can merge histories together as well. And if you think about it, Git is a distributed temporal database, right? So we are storing things. A lot of us use GitHub as our websites as well, right? So we are storing things in GitHub. Good or bad idea how big the file is, that's up to you. But temporal, yes, definitely it's temporal. It is distributed because a lot of us can collaborate on a single GitHub repository, right? So we can have our histories, we can change and merge and fork and things like this, right? So how does this all map to a database? So I wanna mention 3 examples here. There are a lot more here. So CRUD is something that I use a lot nowadays, and special mention about Jeremy, one of the people who works for Juxt. He is there with us right now in the call as well, and at Slack. So any questions that you have, you can go at any depth with CRUD. He's there to answer that as well. So Jeremy is at least there. I'm not sure about James, but Jeremy's there. Right. So CRUD is something that I use a lot. Datomic is the database that's created by the creator of Clojure. Right. So I want to say Datomic introduced this idea to the mainstream, like, can our databases behave like that, like Git, like things that do not change, right? And it has been built for scale like CRUD as well. CRUD is a bit different, saying that it's a more document-oriented DB, schema-less, and it has bitemporality, more than one axis of time, but you can catch up with me or Jeremy on what bitemporality is, right? But Datomic, unfortunately, is still not open source yet, but Data Hike, you can try it out as a drop-in replacement for Datomic. Not built for scale, but you can use it out. Right, so these 3 things, and especially I'm going to mention about CRUD right now because that's the one that I'm most familiar with. So I'm going to change the view that we look at database a bit. Can we rethink about the CRUD word here? Right? So how do you remember CRUD? RR, like pirates, right? So we can say RR, right? Assertions, reads, accumulations, and retractions. Right? So assertions are the fact that we assert that something is there or not, like it's like a select statement. So we assert it to be true, false, or false is basically it's false at that point of time. Reads are of course fine because the database is probably ACID compliant, so we can read consistently from it, right? And we use it as a database value. So given a database, we make the read. And of course, inserts are now accumulations or accretions, right? So we only accumulate newer and newer things, right? And retractions, like we do a git delete or deletion in a git, and then we still make a commit and we assert the fact that it's not true at this time. We don't forget the fact that it was there before, something like that. Right? So, and again, the important thing is whatever we do, the thing that's there in the beginning is still the same, right? So let's look at a small CRUD example. So we have cities, Berlin here. So this is Clojure code. You don't have to understand how this thing works, but just for the sake of this, just imagine this as key value pairs like JSON, right? And a list of things, right? So we say put into CRUD a city, Berlin, which is a capital, has a particular population and belongs to a country. So then we put Barcelona with some population again and belongs to Spain. Then we put Berlin again, this time with more population. That 200 is just a marker there, that's not syntax, right? And it's still the capital. And now we put Berlin with a wall. So 1960s happened and Berlin has a wall. Right? So if you notice here, we are always doing a put. We don't do inserts, we don't do updates, it just put. Right? So that's quite important here. Right? Then we create London, again a put, right? With certain things with capital being true. So, and again, London with a bit more population, right? So now we put Berlin without the wall here. 1990s happened, Nena sang her song, and now we do not have the wall, right? So what happens if we look at the history here? So in traditional databases, if you would have been doing updates everywhere, when you do a select of something, you'll only get the notion of now, what's now. We never get what we came from, right? So if you look at the history from CRUD, so CRUD is remembering everything. CRUD tells you exactly what Berlin went through, right? So each of this ID that you see is a unique reference to a document being a key and value store, right? So that's easy. I mean, CRUD just remembers everything, and then we don't have to worry about all of this updated, created, deleted. Right? So this is data log. So this comes from a language called Prolog, which is even older. I highly recommend you to look at Prolog and data log by extension. So I think I'm not wrong when I say it is a superset of SQL, and all SQLs can be compiled down to Prolog, to data log as well. Right? So here, how do you read it? Given a DB here. So find the city. What is a city? City has a attribute called capital. And if the value is true, so we are trying to find cities that are capital, right? So find city where things. So Prolog is quite declarative, or data log in this case. It tries to fill in the blanks here. Right? So here the blank is city. Right? So now we get Berlin and London because both of them have the attribute called capital and it's true. Right? So now something happened. Berlin is no longer the capital anymore for whatever reasons, right? So we put that in, and then we again try to run the same data log. So this is Crux's flavor of data log. The real data log, it looks a bit different, but it's quite the same in a sense, right? So now it's only London. Right? So again, so since we are querying against the latest known DB, so that's how it behaves like a usual DB, right? But now this is the magic. But what Crux or any temporal DB brings in is we can query the DB as a point in time, as a data structure, right? So we can reset the DB back, right? So older time is a variable here which says that, okay, I want to query at a time before Berlin was removed as a capital. And now we say, okay, make a DB at that older time, give me a DB from that time. This is like saying git checkout. Okay? And then run the query there, right? So now again, Berlin is the capital, right? So we didn't change anything in the DB. We just said that at the older DB, make that query. So this is just one of the things that these kind of DBs give you. It's a lot of power here. Right? So time travel is here. Right? I think that was one of the things that I was trying to assert in the beginning. Right? So we can go back and forth now. I mean, we can't go forward, I guess, but at least we can go back. Right? So someday we'll also go forward, maybe. If you believe in Einstein's things. Right? So, okay, so one of the things that I want to assert here is the value of values. One of the talks again by Ritsuki, the see everything as value. What do I mean by a value? Value is a fact or a piece of information at a given point in time. Right? So I am in Berlin. I could be in some other place at different time. I was in India. So these are all values of me. Right? So try seeing everything as values. And of course, this talk, value of values. Again, mind-bending, really awesome talk. So let's look at a bit into Crux quickly, right? So Crux's architecture, again, is quite different from the way we look at database as black boxes, opaque boxes. So Crux here breaks it down like other DBs as well, and to an unbundled architecture, right? So we want to say we have transaction logs, we have document store, and then the node, the place where we do the query is in your application itself. You don't run queries inside the one thing anymore. So query is with your app now. And you have the transaction log, which records the events, like James was saying in the beginning. And document is a thing that actually accretes the things that you want to represent, the cities, right? So for each transaction, we are creating the document store. And if you notice here, we are not reinventing the wheel. We just use Kafka here or JDBC or S3 even. Just Crux simply piggybacks on things that are existing. We do not want to rewrite things anymore, right? And the query has simply moved inside your app. It's just a library. And then when you query the thing, you have the DB with you. You have the caching with you. So similarly, how Datomic works here is quite in similar way. So if you see all the peer library or the clients has moved inside the app. So more apps that you have, the more scaling that you have right now. You don't need to worry about that one scaling point. So this is quite a difference in thought process, and you get automatic caching here, right? So we don't have to worry about putting some cache in between the database, right? So because the queries are with you now, it's not going all the way there. So it doesn't have to, even the query ones don't have to go all the way to the storage layer, right? So there are different architectures, Crux and Datomic. They have their different design choices, but we're happy to answer all of your deep questions as well. right? So given that, so now that we have all of this in mind, how does all of this affect us? Not just the code that we write, but us as developers, right? So now time is first class. So we don't have to worry about these external complexities of how to manage time, how to do things, right? And more importantly, your database has become a value now. It's not just a connection. It's a thing that you manipulate, that you live and breathe with, right? And it's like any other data structure that you have. It's a hash map, it's a vector, it's a list. So it's going along with your thing, and then you manipulate it, and you can even bring it back to another thing, right? So databases need not be separate. Operational and transactional analytical things, they don't need to be separate. You can do that for performance reasons, but you don't have to. Right? So, and of course, a big heavy query wouldn't stop everyone, because queries are with you now inside the app, right? And most importantly for me, I believe this makes all our applications infrastructure much simpler. If you think about it, one of the reasons we log so much is because our applications are DBs, everything forgets. And we need a way to know what happened. Why did we crash? That's one of the reasons we log. So if our DB never forgets, we can just rewind the DB back, right, to another place, right? So I've been toying with this idea for a while. And since I do a lot of infrastructure code and a lot of closures, so I've been building something called Bob the Builder. Very lazy naming, if you ask me. It's written in Clojure, but more importantly, it's powered by CRUD, right? And the website's there. I can share the link later on as well. So what happens if in a CI/CD system, if you replace the DB with a temporal DB record, right? So now you have this amazing ability to make the entire CI/CD time travel, right? So for example, if you had a bill maybe last Friday and you're back on Monday and you want to check like what happened in that bill. So you don't have to check the logs anymore. You can ask the CI, can you become last Friday? So the CI time travels back. The real thing is still running, but you get a snapshotted value of it. Like if you remember how we queried the capital Berlin again. So now we have this entire piece of infrastructure time traveling, right? Because that is the core of everything, the database, right? All your schemas, builds, and things like this. So now with data log again, you have an endpoint called query, and then you can run pretty much any query against the thing, and you can pretty much query the entire infrastructure of the CI, frozen in time. Right? So for me, this is an incredible thing, and it's only possible if you start thinking functionally at the DB as well. Right? So to wrap it all up, there's a lot of resources and a lot of words that are used here. And one of the things that I would want to emphasize is none of these ideas are new. These are just very old things finally gaining traction because the hardware has finally caught up. So a lot of things here like value of values, CRUD, Datomic, Data Hike, and a lot of talks here. Every one of them is highly recommended. And most importantly, Nena's 99 Luftballons, the video there. Fun song for history buffs, people who really want to see why Germany is Germany, right? So I want to just wrap it up and saying that that's what makes Berlin, Berlin, the colorful Berlin. And since we are nearing the end of pandemic, people are back as well. So hopefully that's what we can do with our code, our lives, and remember what makes us the way we are. Right? And with that, I would like to thank you and hope that people can get something useful out of it. And hopefully this is practical enough. And I'm open for questions. Thank you.